Okay, for part 2 of Professor Klein's lab, we're looking at the wine bridge oscillator. Now the goal of this part was to make an oscillator that runs at 1 kilohertz. And in order to figure out which R's and C's to use, we had to get the transfer function of this circuit. And if you notice, this is just the non-inverting op-amp topology where the gain is set by R1 and R2 ratio. As for the positive feedback loop right here, we can view R and C as two impedances, and in that way we can find the output voltage as a function of the input voltage using voltage divider equation. So the output voltage equals Z2 over Z2 plus Z1 times the input voltage. Now using that technique, we found this transfer function, and if we simplify and use R equals R in both cases and C equals C, and omega equals 1 over RC, the transfer function simplifies just to 1 over 3, meaning that J completely cancels and we have a 0-degree phase shift, which meets the first criteria from Barkhausen's for an oscillator. And the second criteria for Barkhausen's is that we have unity gain. If you notice, the transfer function tells us that this circuit attenuates the output, it attenuates the input by 1/3. And in order to get unity gain, we need to add a gain of 3 to overcome that loss. If we plug in R2 equals 2 times R1, we would get a gain of 3. And so we built the circuit on the breadboard. Initially, it doesn't oscillate. So any random noise on the input is just not enough to make it work. We need to add a little bit more gain initially. So what we're doing is putting this potentiometer in the circuit in series or in parallel, and it adds a little extra gain. Now there's too much gain because, as you can see, it's clipping, it's hitting the rails, which are set right now to 15 volts. But if we take that extra resistor out, we get just the right amount of gain and we get this nice sine wave.